Hello, geometry scholars. It's Mrs. Gregerson on behalf of the math department as we're teaching you how to simplify radicals. And we're reviewing because we need to know it before we do the Pythagorean theorem and working with right triangles and using it for the rest of the year. We have to know how to put things in simplest radical form. Unfortunately, I have a cold, so please forgive me on this. But let's review a little bit from what we did on Friday. So our previous lesson that we did was radicals. This should say day 2, I just realized on top of there. Oh well, we'll fix that on your notes. So simplify the following. So let's simplify -5 times the square root of 80. Well, we know 80 is not a perfect square number, but we do know that we can take a perfect square number out of 80. Well, what's the largest one that we can take out of 80? Well, it's 16. So that's going to be 16 times 5. And notice how we split the two into two separate ones. Remember, the middle one, the radical, is supposed to be our perfect square numbers, and on the right are the numbers that don't have perfect square number factors. So here we got the -5 times what's the square root of 16? 4. The radical 5 on the right comes along. We multiply -5 times 4. That's a -20 root 5. So it wasn't too bad, right? So with this, we just have to make sure it's in the simplest radical form. No decimals, and don't have to worry about rounding or anything like that. Just simplest radical form. All right, so the next one is the square root of 490. Well, I want to simplify this and take a perfect square out of it. Well, I hope you realize that 49 is a perfect square number, and 49 times 10 is the square root of 490. So we take the square root of 49, well, that's 7, and with the square root of 10. So yeah, so those are our perfect square numbers so far. Let's hopefully remember the rules of simplifying radicals, adding, subtracting. Remember, we simplify each term first. So we go here, we get 3 times the square of 16 times root 3. And then what do we simplify 27 into? We get the square root of 9 and root 3. Well, what's this? 3 times the square of 16 is 4 times root 3. So we get 4 here times the square root of 9, which is 3, root 3. Now look what we get here. 3 times 4, that's 12 root 3. -4 times 3 is -12 root 3. Now here's my question for you. Do I have the same radical in the denominator? Remember, it has to be in simplest radical form. They both have the same radical in the denominator. Underneath the radical. I said this earlier in a different video. I was like, numerator. Didn't mean to do that, sorry. So both same number underneath the radical. So we get 12 root 3 minus 12 root 3. What the same thing minus itself is just 0. You could say 0 root 3, but what's 0 times root 3? 0. So the answer is just 0. That's it. All right, let's try the next one. We got the square root of 288 plus 3 times the square root of 150. Well, those look like really large numbers, totally out of control. But remember, guys, you were supposed to memorize to 20 squared anyway, probably last year when you were working with it. But the cool thing is, with the square root of 288, you can take out 144. Well, 144 times 2 is 288, and 144 is a perfect square number. All right, so let's take out this perfect square number out of 150, which is 25. What's left in the radical on the right is 6, so 6 times 25 is 150. Guys, what's the square root of 144? Well, that's 12 root 2. What's the square of 25? 5. 5 times 3 is 15 root 6. Now here's my question. Do I have the same number underneath the radical? No. I have a 2 here and I have a 6. Well, that means as long as those are in simplest radical form, I can't combine them any more than what they are. So my final answer is just this. Sorry, let me get this. It's just 12 root 2 plus 15 root 6. All right, so now let's do some simplifying of radicals or new stuff. We're going to multiply and we're going to divide radicals and work with fractions now. So remember, fractions is division. I just want everyone to remember that. You're comparing one number to another. That is a fraction. It's division. But when you're multiplying radicals, it's basically like the same process if you're multiplying two numbers together with variables. Like for instance here, how do I multiply 3x times 2x? Well, I multiply the 3 and the 2 together to get 6. Then I multiply the two x's together and we get x squared. So that's not hard to do. But what if I had something like this? 4x times 5y. Well, how would we still multiply those two numbers together? Well, we'd still multiply the 4 and the 5, which is 20. But I can't multiply the x and the y, so I would just multiply it by and go x, y. So remember, we'll use some of those same techniques when we're working with multiplying square roots or radicals. So in this first problem here, so let's just practice this. We get a negative 5 root 8 times 4 times the square root of 3. So we do the numbers out front together first. So I got a negative 5 times 4. That's a negative 20. Then we're going to multiply the numbers underneath the radical together. Now, remember, we kind of went reversed. Like, look up here on A up above. Remember, I know 16 times 3 is 48, so I split them apart. Well, basically, we're now putting them together. So it's 8 times 3. Well, that's 24. So it's a negative 20 times the square root of 24. But before I'm done, I'm like, ooh, I'm done. I multiply together. You can't do that. When you work with radicals, you always have to make sure you go to simplest radical form. So I have to look for a perfect square number that comes out of 24. Well, 4 does. So I get 4 times 6, right? 24. Well, what's the square root of 4? Well, that's 2. So negative 20 times 2 times the square root of 6. Well, negative 20 times 2 is a negative 40 root 6. Simplest radical form. What do you guys think? Not too bad, is it? Do you remember? Hopefully. Now, here's the thing I was emphasizing with my advanced students. If you don't remember, you got to come find us. You can come to Mrs. Young, or you can come to Mrs. Prempis, or myself, or any other geometry or math teacher out there. Algebra teacher even. You have to know how to do this in order to go on with the further stuff that we're doing starting in Chapter 8, our Unit 8 chapter. We are working with the Pythagorean theorem and a whole bunch of stuff with radicals. And if you can't do the square root, you're not going to be able to do stuff with area, and you're not going to be able to do a lot of other things with geometry. So we need to make sure you know how to do this. All right. So off my high horse to make sure you remember how to do this. But let's go ahead and multiply again two radicals together. All right. Why did I put a 1 in front of each one of those square root signs? Well, there's no number there, but what's understood to be there? What's understood to be the number 1. So if you need to in your brain go 1 times 1 to get 1, that's totally fine. But now we're going to multiply the two numbers underneath together. So we get 36 times the square root of 8, and you get 288. Well, remember, I can take the square root of 144 out, and I get square root of 2. Well, what's square root of 144? Well, that's 12 root 2. Now, that's one way of solving this one. So what if I'm going to show you, and I'm going to do it in a different color. Let's pick red, just to contrast a little bit. What if I wanted to take the square root of 36 times the square root of 8, and I want to do it differently? Well, here's another way you could do this. Guys, what's the square root of 36? 6, okay. What's the square root of 8? You go 2 root 2, right? Because remember the square root of 8, let's go over here. Remember it's the square root of 4 times the square root of 2, so that's going to be 2 root 2, right? Okay, now, can I go ahead and multiply these together? I can. What's 6 times 2? 12 root 2. So, if you want, you could simplify each radical before you multiply them together. Either way is fine because you're going to be able to simplify it. So just either know, I don't care which way you do it, long as you do it right and well. Just another option for you. All right, now let's go ahead. I'm multiplying fractions together now. I mean, what am I thinking? Well, just remember when you're multiplying fractions together, numerators together, denominators together, okay? So looking at this, you can multiply the numerators together. You get the square root of 60 over the square root of 5 times 5, which is 25. And I have getting over here the square root of 60 over 5, but I still have to simplify the square root of 60. Well, 4 can come out. So 4 times 15, the square root is 60. So 4 times 15, so I leave over 5. Well, what's the square root of 4, guys? 2 root 15 over 5. Now, one thing when you have fractions is you have to always double check a couple of different things. First of all, you always have to make sure these numbers are in simplest form. So like just with fractions, how fractions always have to be in simplest form. So when I don't have a radical symbol, like I have like 2/5, I have to make sure it's not 2/4, and I reduce it to like 1/4. And you always have to make sure your radicals are in the simplest form. So hopefully that kind of jars your memory. Now, there's a few things I also need for you guys to remember before we go a little bit further is squaring, square roots. So let's see if I can go backwards just a little bit here. So what if I go the square root of 5 squared? What do we get? We get root 5 times root 5, which is the square root of 25, which equals what? 5. So really, if I square a square root, doesn't the number underneath come out? Right? Okay, so that's one thing that we're going to use to our advantage in math. But what if I have something like this? What if I get the square root of 5 squared? Well, order of operations say do your exponents first. Well, 5 squared is 25. Well, guys, what's the square root of 25? 5. Huh. So what does the square root symbol do with my squared? That's right. They cancel out. So just remember, we're going to actually be using, especially the first example that I use, when we're simplifying fractions with radicals in them, because we're going to use that process, what's called rationalizing the denominator. So let me give you some examples of what we're doing here. All right, so the first one, we have the square root of 8 over 9. So it looks really complicated, but the cool thing is you could sit there and try to simplify the fraction first if they're simplifiable. So just remember you can do that, but since 8 and 9 can't, we're good on there. But you can always rewrite it like the following: the square root of 8 over the square root of 9. Well, then you can simplify the numerator and the denominator. Well, what's the square root of 8? Hopefully, guys, you have memorized 2 root 2. What's the square root of 9? 3. And then I check to see if 2/3 can simplify anymore, and it can. So my final answer for what was our original problem, square root of 8/9, is really 2 root 2 all over 3. Make sure it's in the numbers out front and the outside of the radicals simplify are in simplest form, and my radicals in simplest form. What do you guys think? Not too bad, is it? Okay, well, the next problem is it's 2 over the square root of 7 squared. So that's the same thing as going 2 times the square root of 7 times 2 over the square root of 7, which equals, what's 2 times 2? 4. What's 7 times 7? All right, so that's 49. So I get the square root of 49. So I get 4 7s. What do you guys think? Not too bad, is it? Here's my question. Could I have rewritten this like the following? Right here. Could I have also gone 2 squared over the square root of 7 squared? And what do we get? 4. And remember, we square a square root. Remember up here. What do we get? Yep, 7. So the cool thing is, can we get the same value? Yeah, so there's more than one way. For a lot of you, I'd probably say this is the way for you to think about it now. It's probably the best way of working with what we're doing today. Okay, so what's the key with dividing? Well, remember, division is fractions. We have to make sure fractions are in simplest form, and we have to make sure that we never ever have a radical in the denominator of our fraction. It's called rationalizing the denominator. So first things first, if I have 2 radicals just like this, I always see if I can simplify them first. If you need to, even in your brain, you can even rewrite it like this, 3 over 27. Well, what does that reduce down to? Well, that's 1/9. So can I take the square root of 1/9? Yep. What's the square root of 1 over the square root of 9? The square root of 1 is 1. The square root of 9 is 3. So it's 1/3. That's it. That's how easy it is to do the square root. Now, another way you could have done that is not rewrite it, but just go, I know they're both radicals because I know the 3 can go into the 27, and you've got 1 over the square root of 9 right away, because root 3 can go into the square root of 27, and you've got 1/3. So really it's your way of doing it, but I think this is a great way of working with it. But remember, up above on 1.5a, my 1.5, I know, silly, isn't it? Remember, I split it because I needed to see if I could simplify it. Notice here on 2a, I can combine them together. Isn't that really cool? As long as they're radicals, though, they have to be the same. All right, so the next one, we have simplifying the radical. The first thing I would tell you to do is simplify before you worry about it. Because right now, I got 3, and it doesn't go into 75, square root of 75, because it's not root 3. But I can redo it like this. I got the square root of 25 times root 3. So that ends up being 3 over 5 root 3. Now, the problem is I have a radical in the denominator. So the way that you get rid of that is we can use the process called rationalizing the denominator. You multiply the radical in the denominator by the same radical, by root 3. The reason why I do that is so I can actually do what I just did up here earlier. So that helps me rationalize. But the thing is, I can't change the value of my fraction. So I really have to magically multiply by the number 1. So notice we rotate that, multiply by root 3 over root 3. So I get 3 root 3 over 5 times root 3, which is 9. Guys, what's the square root of 9? 3, right? That ends up being 3 root 3 over 15. Now, most people says, oh, look, we're done. We have 3 root 3 over 15. But we're not, because look at 3 and 15. Can they simplify out? Can I reduce that fraction? And the answer is yes. 3 can go in there 5 times. And so that ends up being root 3 over 5. So this is actually my simplest radical form. Okay, let's try C. All right, for this one, we're going to multiply stuff together first. So we're going to go strictly across. And so I end up getting 8 times the square root of 5 over the square root of 12. Now again, I actually tell people I think you should simplify first before you go any further. So I get 8 times the square root of 5. Well, what comes out of the square root of 12? Well, that's the square root of 4 times the square root of 3. I get 8 root 5 times 2 root 3. Let's rationalize the denominator. What do you guys think? Right? Because I have a radical in the denominator and I cannot have a radical in the denominator. So we're going to multiply by the numerator or denominator by root 3. The reason why I keep using root 3 here, guys, is root 3 is actually a really common one you'll find in the denominator of a fraction. So we get 8 times the square root of 15 over, well, guys, remember this, what's root 3 times root 3? That's 3, or the square root of 9, which gives you 3. So 2 times 3 is 6. All right, so we get 8 root 15 all over 6. Now here's my thing. Are we in simplest radical form? No, we're not. We're in simplest radical, actually I take that back. We're in simplest radical form, but we're not in simplest form because 8 and 6, I can take a 2 out of both. So before that, I have to get the 2 out of both, and I'm going to go to the right here a little bit. So I get 4 root 15 all over 3. Now, do not make the error of going, oh, 3 can divide into 15. No, 3 cannot, because that's square root of 15. It's not the number 15. All right, it's the square root of 15. So this would actually be simplest radical form. All right, so let's finish up by doing 4 examples more of just working with radicals. So a little bit extra practice, and then remember your homework is to download the worksheet online, do it. It's like 15 problems. There's a couple stretch problems. There's some very easy problems on there. And make sure you just turn it in, okay, before class starts. All right, extra practice. What do we do here? Well, I got the square root of 8 squared. Remember, that's the same thing as root 8 times root 8, which gives you what? Excuse me, the square root of 64, which gives us 8. Guys, if you can go from here to here, that's perfect. Also, the next one, we get the square root of 17 squared. Remember, the square root and the squares cancel each other out, and you should just get 17. Now, if you needed to, you could go, that's 289. Well, it's the square root of 289. Well, that's still 17. So it's the same thing. Just some fun stuff to remember. Now, I'm using those concepts like of A and B there, of squaring, square roots, or vice versa. I'm looking at this, and I got 3 over the square root of 6. I can't do anything because I need to rationalize the denominator. So I'm going to rationalize by, remember, multiplying by the radical on the denominator by itself. And then you have to make sure you do it in the numerator. So it becomes 3 root 6 over 6. I then have to check. Remember, I got to check these two right here to make sure if I can simplify my numbers outside the radical, and I can. So that gives us root 6. Oops, I did not get what I thought I had on here. Root 6 over 2. Now that's in the simplest radical form. Remember, the 2 cannot go in the root 6 though, because it's a radical. All right, last but not least, let's do this last one here. Make sure you multiply across, my friends. Sometimes 4 is 28. Root 2 times root 3, that's the square root of 6. Now, what do? We rationalize the denominator by multiplying by the radical in the denominator. So I get 28 root 6 over 6. Now we have to make sure, if we're in simplest form, well, 2 can come out of 28 and 6. And that's 14 root 6, root 6 all over 3. And there's simplest radical form. Okay, guys, so remember your homework is to do the worksheet with 15 problems or so on it. You download it from Academy Central. It's in the same lesson as this video. Make sure you turn it on time before class. And if you don't understand, please go to your geometry teacher and let us help teach you. Or any really math teacher here at Wayne Academy will help you learn it, because we're going to be applying it right away on Friday. So make sure you know it. Thank you. Have a great time. And, well, just have a good day. Just do your math and have a good day.